Hello, this is Gregory Maxwell, and this is the next lesson in mathematics. This lesson is about mathematical modeling or solving applications of quadratic equations. Um, I give a PowerPoint credit here to Professor Shauna Hader from Salt Lake Community College. Most of the slides from this PowerPoint were created by her with a few modifications. So now let's get into the lesson today. When you're solving word problems, it is best to follow a simple approach. There are other approaches, but this approach I found to be very effective. I call it the REST method, R-E-S-T, R-E-S-T. The R stands for read the problem. E means explore the problem. S stands for two things, come up with a strategy and use that strategy to solve the problem. And then T stands for testing the solution to see if it makes sense. So read, explore, strategize, and solve, and test your answer. REST. Let's break this down a little bit. What does it mean to read the problem? First of all, you're going to read the problem all the way through before you do anything else. And then you'll go back through and read a second time and ask yourself the question, what do I need to find out? In other words, what is the question asking you for? The aim here is to understand what the problem is about and to help you to figure out whether you've found an answer or not. If you have not answered that question satisfactorily, then you have not solved the problem satisfactorily. Diagrams, tables, charts may be very useful in this at this point. Directly connected to reading the problem is exploring the problem. To explore really means to look for information provided. The basic question you will be answering here is what information is given either explicitly or implicitly in the question, and what information is not given that you need to find out. So what you want to do is assign symbols to certain quantities, in particular the quantity that you need to find out. So that way, once you find the quantity, you've found the solution. You may have to make a few adjustments to this approach, but generally it works. And again, diagrams, tables, charts will definitely help in this regard. After exploring the problem and identifying what the question is asking for, then you need to come up with a strategy and then use that strategy to solve the problem. The basic question here is how can you use what is given to find what is requested? How can I use what I have to get what I want? This usually involves some formulas or equations, and this depends on what the question is asking you to do. So you can't just randomly put formulas there. If the question is asking you for a certain thing, then you use a certain approach. This, of course, is the hardest part of the process. After you solve the problem, then you want to test your answer to see if it makes sense and see if your answer fits the criteria. So the basic question here is, does my answer make sense? And you want to make sure that you answer the question that is asked. If the answer does not make sense, then chances are your answer is wrong. Please be sure also that your answers are in the correct unit of measurement. If it's area, it must be in square units. Speed, meters per second or feet per second. You need to make sure your units are appropriate. So those are the four steps. REST. Read, explore, strategize, solve, and test your answer. Now, before I go on to do some examples, I need to point out two more things. The use of tables. Tables are extremely useful when solving word problems, but sometimes people have difficulty making tables. So in a few examples here, we'll learn how to create tables to help us to organize the information. So when we're doing the tables, you may want to first create a column that identifies the type of quantity, whether it's a type of mixture or a type of savings, CD, a certificate of deposit versus a savings bonds. If it's an interest problem, different types of questions require you use different types of quantity. The middle columns are some type of listing of the information that is provided, the numbers of quantities or the amount of the quantity, and also what variables you're going to be using. And the last column is usually some way of combining the middle columns by some formula. We'll see some examples as we go along. Next, A few important formulas that you need to know. Should know the simple interest formula, which it says the interest is equal to the principal times the rate times the time. The rate is usually per year and the time is in years. And the rate is written in this formula as a decimal. So if the rate is given as 5%, then you would convert that 5% to 0.05, which is the decimal version for 5%. Mixture problems, the amount of pure substance is equal to the concentration multiplied by the volume. The concentration is the fraction of the mixture that is pure substance, and the volume is how much mixture you have in all. So the amount of pure substance is the fraction of the mixture, that's the pure substance, that's the concentration, multiplied by the amount of mixture you have. So if the concentration is say 10%, and the volume is 50 liters, then what we're saying is 10% of that 50 liters is pure substance. So we find 10% of 50, which would be 5. Other formulas to know, sorry about that, this should say uh, speed or constant rate problems, not simply interest. So the speed problems or constant rate problems are distance is equal to rate times time. So that's a basic formula. It's analogous to the mixture problem, where the distance is like the pure substance, the rate is like the concentration, the time is like the volume. So they have similar ways of approaching. And of course, you should also know geometry formulas like the Pythagorean theorem. Leg squared plus leg squared is equal to the square of the hypotenuse. You should know areas, volumes, and surface areas of basic shapes, areas of triangles, rectangles, parallelogram, trapezoid, circle, square. Um, you should know the volume of a sphere, prisms, the cylinder, the cone, pyramid, and for some of these you should also know the surface area. Here are some formulas for areas of two-dimensional shapes. The rectangle is base times height or length times width. Square is base times height or length times width, or since the sides of a square are all the same, just multiply a side by itself. Here for triangle, the most common formula is half base times height. Area is equal to half base times height. Parallelogram is base times height. Circle is pi radius squared, pi times radius squared, and a trapezoid is half times the height multiplied by the sum of the bases. The bases are the lengths of the parallel sides of the trapezoid. And also some volume formulas. Volume of a cube is the length times the width times the height. Volume of a rectangular prism, length times width times height. Volume of a sphere, 4/3 pi radius cubed. Volume of a right circular cylinder is area of the base multiplied by the height, and since the base is a circle, it's pi r squared h. This formula is missing the r, so let me correct that right now to illustrate. So the formula should not be pi squared r h, but it should be pi r squared h. So let's correct that at the moment. Pi multiplied by the radius squared multiplied by the height. And then, of course, for a cone, it's 1/3 pi times the radius squared times height. And for a pyramid, it's the area of the base times the height multiplied by 1/3. So let's take a look at a breakdown of an example here. Simple interest formula. And again, this example was provided by Shauna Hader from Salt Lake Community College. Interest is equal to principal, which is the original amount, multiplied by the rate, which is the interest rate per year, and the time in years. Here's an example. Suppose you borrow $1,000 for 6 months at the simple interest rate of 6% per year. Per annum means per year. What is the interest you will be charged on this loan? If you pay the loan back at the end of 6 months, what is the amount that you must pay? So let's take a look at the first question here. The interest is 1,000 principal times the rate as a percent. 6% is 0.06, and the time is 6 months. So You multiply that by, because you're paying it off in 6 months, it's half a year. You multiply that out, and the answer is $30. So you would owe $30 at the end of 6 months if you're using the simple interest formula. It is that easy. If you know the formula, you can apply it. So this $30, by the way, is not the total amount that you would need to pay back. That's just your interest. You pay your interest plus your original amount. Since your original amount was $1,000, you pay your interest plus $1,000. So you'd be paying back $1,030. So that's the approach there. Let's do a mixture problem. Now, with the mixture problem, I would recommend that you use a table to help you to organize the information. And in a few slides, I will show you how to use a table to organize a few of these types of questions. So, if you have two mixtures and you're putting them together, what you need to do is keep track of the amount of pure substance. So you identify how much pure substance is in the first mixture plus how much pure substance is in the second mixture, and that should be equal to the amount of pure substance in the mixture. Here's an example. How many gallons of a 25% acid solution would you mix with 4 gallons of a 6% acid solution to obtain a 15% acid solution? Now, what you want to do is identify how much pure acid is in the first solution. The concentration is 25%, but we do not know how much is there initially, so we're going to just call that X. So we do concentration multiplied by X. Then for the other mixture, the concentration is 6%, and the amount of pure substance, the amount of the volume, sorry, is 4 gallons. So, so you'd multiply 6%, 0.06 multiplied by 4 gallons. And then the final mixture has a concentration of 15%, but the total quantity is the amount of the volume of the first plus the volume of the second. So here's how the formula breaks down. Concentration of the first mixture multiplied by the amount of the volume of the first mixture. We don't know the volume of the first mixture, so we call that X. Concentration of the second mixture is 6%, so we put that as 0.06. The volume is 4 gallons. So you multiply 6%, 0.06 multiplied by 4. And then that will tell you the amount of pure substance in the first mixture plus the amount of pure substance in the second mixture. And that should be the amount of pure substance in the combined mixture, which is 15% concentration. And the amount of volume is the amount that you had with both original amounts put together. So now we have a simple equation here. This is not a quadratic equation. It's just a simple linear equation, which is easily solved by getting the x's together and solving for x. And there we have it. So the original mixture should be 3.6 gallons. You'll mix 3.6 gallons of the 25% acid solution with the 4 gallons of the 6% acid solution, and you would end up with a 15% acid solution. Here's another example, uniform motion. Distance is equal to rate times time. When in physics, the distance is called displacement. Its symbol for that is S. The rate in this case is velocity. The symbol for that is V. And the time is, as usual, T. So distance S is equal to rate V times time, T. So here's an example. Oh, let's a quick note here. These problems are easy if you have just one distance, velocity, and time, but often we'll have two different situations. The best way to tackle these is with a table to organize the information. So let's take a quick look at this example here, uniform motion problem. A truck traveled the first 100 miles of a trip at one speed and the last 135 miles at an average speed of 5 miles per hour less. If the entire trip took 5 hours, what was the average speed for the first part of the trip? So as usual, you read the problem through, and then when you read it through, you identify what they're asking for. In this case here, we go back through the truck traveled the first 100 miles of a trip at one speed and the last 135 miles at an average speed that's 5 miles per hour less than the original speed. If the entire trip took 5 hours, what was the average speed for the first part of the trip? So the question is asking for the average speed for the first part of the trip. So here's a table. The table gives us the type, some quantities that we're going to put together, and then at the end here, or wait, actually, I would normally put the distance at the end, but the distance will be the velocity multiplied by the time. So for the first part of the trip, the distance is 100 miles. The speed we don't know, v, and the time we don't know, t. So we'll just put v for the velocity and t for the time. For the second part of the trip, he travels 135 miles, and the speed is 5 miles per hour less than the original. So we would subtract 5 from the original velocity, and the time in all would be 5 hours. So if you went t hours before, then you use the rest of the time for the second part. So you would say 5 minus t because it took 5 hours in all for the whole trip. And then we can use the fact that when the total amount of time for the trip is 5 hours, we can now put this information together. So let's put this information together. The distance for the first part is 100 miles, and the speed is v, and the time is t. The second part is 135 miles, and the speed is v minus 5, and the time is 5 minus t. So what we do, we just solve for one variable. So we can isolate the t, sorry. And once I isolate the time, now I know that the time is 100 over v. I will just take that from the first part and substitute that into the second part. So effectively, I'm solving two equations with two variables. I get one variable by itself in one equation, and I substitute that into the other equation. And now my equation only has v's, and once I solve for v, that will give me my initial speed, average speed. So what I'm going to do here is I will distribute the parentheses. So I'll multiply v times 5, v times negative 100 over v, negative 5 times 5, and negative 5 times negative 100 over v. And that gives me this equation here, which I will then combine like terms, and then I will multiply both sides by v so that I do not have it in the denominator. So now my equation looks like this. 135v equals to 5v minus 5v squared minus 125v plus 500. I set everything equal to 0 by moving the 135v to the left side and combining it with the negative 125v. And then I will solve this equation. Everything is divisible by 5. I divide both sides by 5. And then I can just solve this by one of the quadratic methods that we learned before, which is quadratic formula, factoring with zero product property, or completing the square. In this case, we can factor very easily. We just need two numbers that multiply to be 100 and add to be negative 52. Those two numbers are negative 50 and negative 2. So the expression on the left side factors to be v minus 50 multiplied by v minus 2. And then we set each part equal to 0 and solve. So the initial speed is either 50 miles per hour or 2 miles per hour. Now 50 miles per hour makes sense, but 2 miles per hour does not make sense because then the second side part of the trip would be going at negative 3 miles per hour, which does not make sense. So then the only reasonable answer here would be 50 miles per hour. So we have to ignore or eliminate the 2 miles per hour. That is what we call an extraneous solution. It came up as a solution legitimately through good mathematics, but it is not a natural solution to the question. The actual solution is 50 miles per hour. Let's do one more example here, and then we will go into some others as well, which I'd like you to try before I go through them. An office contains two copy machines. Machine B is known to take 12 minutes longer than machine A to copy the company's monthly report. Using both machines together, it takes 8 minutes to produce the report. How long would it take each machine alone to reproduce the report? Now, in this case, I'd like you to pay attention to how much is done in each unit of time, because that's the key for you to identify how much is done, how long it takes to do the reports together. So going back to the problem, we see that the question is asking how long will it take each machine alone to reproduce the report? So we're supposed to get two answers here. A table is also very useful here, but we'll go through the PowerPoint and then see how to use a table in another example. So what is the work done by machine A? It's the rate at which machine A is doing the work multiplied by the time it takes to complete the job. So machine A takes um, takes 8 minutes to do the one job, right? And you multiply that by 1 over t, which is the time it takes to complete the job, all right? And then machine B takes 12 minutes longer than machine A. Oh, pardon me. Let me repeat that. Machine A takes t minutes to complete the job, and machine B takes t plus 12 minutes to complete the job. And what we do is we we multiply the time it takes to complete the job alone by the time it takes to complete the job together in both cases, and that should add up to be 1. Now, once we do that, we have an equation here that we can solve very easily. We just multiply by the common denominator both sides. And once we multiply both sides by the common denominator and simplify, we end up with a nice equation here, which when we distribute and combine like terms, we end up with a quadratic equation, which we can now solve by one of the quadratic methods. Again, we're going to factor this, and we have 12 t minus 12 multiplied by t plus 8 is equal to 0. We solve for t by using the zero product property, and again, using some common sense, -8 does not make sense because you wouldn't use -8 hours or minutes to come to do the copying. 12 minutes for machine A would make sense, which means that machine A would take 12 minutes and machine B would take 12 more minutes, which is 24 minutes. All right. What we're going to do here is we're going to go on to doing some additional examples, and then which I would like you to try on your own, and then check the video to see how what the solutions would be. So pause the video once I put the question up, and then try the question on your own, and then check the video to see the solution. Okay, let's take a look at the first question, the first example. As I said before, I'd like you to try the question by yourself, and then you can check the video to try this on to check your answer. It says, working together on a job. Trent can deliver his newspaper in 30 minutes. It takes Lois 20 minutes to do the same route. How long would it take them to deliver the newspapers if they work together? So once we read the question through, we go through and we say, okay, they're asking how long it takes for them to work together to complete this job. I recommend you reread the problem to make sure we have a clear understanding. So, and then we say, find, let's change the color here, find the time to complete the job together. And we're going to call that T. Now, let's do a little table to help us to organize our information. The first column of the table will be who's working. That would be the type of person. So we're talking about two people and then both of them together. So we'll have a row for Trent, a row for Lois, and a row for them working together. So we have Trent, Lois, and both of them together. I left the top row empty because I want to put headings for my columns. I'm not going to put a heading for the first column, but for the second column, I want to find out it's how long does it take him to do the job. So time to do the job. Trent takes 30 minutes, and Lois takes 20 minutes. And the time they will do it together, let's see how much time that is. We don't know that. That's what they're asking us to find. So we're going to call that T. Now, it's a little tricky here, so you have to pay close attention. And I'd like to point out here that the only real way of getting good at word problems is by doing word problems. You can't just watch someone do them, you have to try them on your own. Now, what you want to do is find out how much of the job is done in each unit time. So we want to find out the amount done per, in this case, minute, per minute, because that's the unit of time. If it takes him 30 minutes to do all the papers, he would have only done 1/30th of the job in 30 minutes, in 1 minute. And Lois would have only done 1/20th of the job in 1 minute. And if they were working together and it would take them t minutes together, it would have only taken them 1 over t, only 1 over t of the job would have been done in that time. Now, the reason we do that is this. Relatively simply, here's what's going on. The amount that Trent does in 1 minute plus the amount that Lois done to get in 1 minute is the amount that they will do together in 1 minute. So the amount done by Trent in 1 minute plus the amount done by Lois in 1 minute, and we're assuming they don't interfere with each other, is the same as the amount done together in 1 minute. So the key here then is to add these two quantities, 1 over 30 from Trent's amount done in 1 minute, plus 1 over 20 for Lois, and that will be how much they do together in the 1 minute. And all we have to do now is solve this simple equation. We multiply both sides by the common denominator, which in this case is 60t. So I'm going to multiply the left side and the right side by 60t. And what that will do is allow me to cancel the denominators. Once we do that, we now have 2t plus 3t is equal to 60. And that's because the t on the right side of our equation canceled. And of course, 30 goes into 60 twice, and 20 goes into 60 3 times. So the question simply becomes 5t is equal to 60, and then that means t is equal to 12 minutes. Now, does that make sense? If they're working together, it should take less time for them working together than either of them working alone. So the answer we get should be less than 20, and the answer we got is less than 20. And there's also other ways to check the answer. So the solution to this is the time, the amount. The question is asking, how long would it take for them to deliver the newspapers if they work together? Time to deliver newspapers together is 12 minutes. Let's take a look at the next question. Now, let's look at a few examples of applying word problems to quadratic and linear situations. Continuing from what we left off before from the PowerPoint Now let's take a look at this question taken from the book Pre-Calculus 5th edition by Blitzer. A pool measuring 10 meters by 20 meters is surrounded by a path of uniform width. If the area of the pool and the path combined is 600 square meters, what is the width of the path? So we look at the question and we realize it's asking us for the width of the path. So what we will do is we'll go back through the question and represent the information that they give us. So let's go here. They say a pool measuring 20 feet, 10 meters by 20 meters is surrounded by a path of uniform width. So if I were to represent that, this is not going to be drawn to scale, of course, but let's just say that this is the path and the pool. So this pool has a width of 10 and length of 20, or you could meters. Again, not drawn to scale. And they said to find width of path. So we're going to find path width, which we will call x. So remember now, the first thing you want to do is ask what is the question asking for, and you draw diagrams or use tables to help you to organize that information. Now let's explore it to see what information is given. The diagram tells us that the dimensions of the pool is 10 by 20, and if the area of the pool and the path combined is 600 square meters, then that means the whole coverage, because area is the covering of the surface, total amount of surface covering. So that means it's this for this side here, the shorter side. This is 10 meters plus another x meters and another x meters there. So that's 10 meters plus 2x meters. That's your width. And then for the length of the pool, we're talking about 20 meters plus 1x on this side and 1x on that side. So it's 20 meters plus 2x meters. And the total area is equal to 600 square meters. Now, please note now, this is a rectangular pool and a rectangular border overall. So what we will need to do is use the formula. Area is equal to length times width. And in this case, the area of the total surface area covering is this bigger rectangle, 600 square meters, and the length and width are 2x plus 20 for the longer side and 2x plus 10 for the shorter side. And what we have here is a quadratic equation. You will see that when we distribute the 2x plus 20 and the 2x plus 10, and then we will proceed and see what we can do here. So 600 is equal to 2x times 2x is 4x squared, 2x times 10 is 20x, 2x times 2x is 40x, sorry, 40x, and 20 times 10 is 200. You may notice that each of these numbers is a multiple of 4, and that's important because we want to make it as simple as possible. So I'm going to divide everything by 4. So I have x squared plus 5x plus 10x plus 50. And then, oh, I forgot to, 600 divided by 4 is 150. You can just check that on your calculator. Since it's a quadratic equation, we can set everything equal to 0. So I'll write it over to this side here. And we have x squared. I'm going to subtract 150 from both sides. So x squared plus 15x minus 100 is equal to 0. When I subtract 150 from both sides of the equals, and then I also combine the x terms, we end up with this equation. And now we can simply solve this by quadratic formula or by factoring. Let's see if we can factor this. We need two numbers that multiply to be negative 100 and add up to be 15. Of course, one number has to be negative and the other number has to be positive. The larger being the positive number, that means that it would be 20. And because 20 times negative 5 is negative 100, and 20 plus negative 5 is positive 15. And then we set each part equal to 0, so that means x minus 5 is equal to 0, or x plus 20 is equal to 0. And then it's pretty straightforward from here. We see that x is equal to 5, or x is equal to negative 20. So since this x represents the width of the path, and that is what they're asking for, we recognize that the path cannot have a negative width, so the negative 20 cannot be the answer. So then the solution then is the width of the path, which is what the question asks us for, and that is what our variable is x equal to 5. Well, let's not use x, just with 5 meters. Then I will leave it to you to check to see if that makes sense. Let's move on to the next example. A tree is supported by a wire anchored in the ground 15 feet from its base. The wire is 4 feet longer than the height that it reaches up on the tree. Find the length of the wire. So they want us to find the length of the wire. So if we look at this carefully, the ground typically is represented as a horizontal line. So let's draw a horizontal line for the ground. I'll draw a green horizontal line here for the ground. And we have a little tree, which I will use as a black um, vertical line because the tree typically grows vertically. And then the line is stretched to the ground. So the question is find the length of the wire. So we're assuming that the wire then, we'll call that x. So as you notice here, this is a right triangle because the tree is perpendicular to the ground. A tree is supported by a wire anchored in the ground 15 feet from the base. So the anchor here is 15 feet from the base of the tree. And they say the wire is 4 feet longer than the height that it reaches a tree. So that means if the wire is 4 feet longer, then the height it reaches a tree is 4 feet shorter than the wire. So the wire is x, so the height of the tree is x minus 4 feet. And as you can see, it's a right triangle. Generally, whenever you see a right triangle, think Pythagorean theorem. You may not always use it, but it's always good to think about it. Leg squared plus leg squared is equal to the square of the hypotenuse, or a squared plus b squared equals c squared, as long as c is the hypotenuse and then b are the legs. Now, the Pythagorean theorem is used to find missing side lengths if you know 2 of 3 sides of a right triangle. And this, in this case, is a relationship among the sides of a triangle. So we're going to do that approach. We're going to do a squared, or 1 leg squared, x minus 4 squared, plus the other leg squared, 15 squared, is equal to the hypotenuse squared, x squared. And then we just proceed from there. Now this looks like a quadratic equation, but we have to make sure. So we're going to have to distribute this x minus 4 because it's squared. X minus 4 multiplied by itself, and 15 multiplied by itself. 15 multiplied by itself is 225. When we distribute, we get x squared minus 4x minus another 4x plus 16 plus 225 is equal to x squared. And then combining like terms, since that's a quadratic, we're going to subtract x squared from both sides to get everything equal to 0. I'm going to combine these, and I'm going to combine the 16 and the 25. So when I subtracted x squared from both sides, it just turns out that both parts cancel. So it turns out this is not a quadratic after all. It is simply a linear equation. And then 16 plus 225 is 241. So then we solve for x. Negative 8x is equal to negative 241. And then we divide both sides by 8. So we get negative 241 over negative 8, which is equal to a positive 8 into 240 is 30. So we have a 30 and 1/8. So the length of the wire is 30 and 1/8 feet. All right, and there we have our answer here, and it only goes up 26 and 1/8 feet up the tree. Now let's go on to the next example. This example is from the pre-calculus book by Blitzer. Suppose that we agree to pay 8 cents for every problem in this chapter that you solve correctly and fine you 5 cents for every problem done incorrectly. If at the end of 26 problems we do not owe each other any money, how many problems did you solve correctly? So the question is, how many problems were solved correctly? So let's see how we're going to do that. So we have 26 problems in all, and we do not owe any money, so that means we break even. Suppose that we agree to pay 8 cents for every problem in the chapter that is solved correctly. So we're gonna do, let's say, let x equal to number solved correctly. Now, we did 26 problems in all right? 26 problems in all. If we solved x correctly, that means the rest were not solved correctly. So, number uh, number done incorrectly would be the leftovers. So that would be 26 minus x. And so now, if you get paid 8 cents for each problem you get correct, so that would be 8 times x would be the total amount of money. Well, in cents, the total amount of money in cents that you would have gotten from solving the problems correctly. But then, if you lose 5 cents, then that would be 5 times 26 minus x. Now, let me just do a little side note here. Another way of looking at this would be saying positive 8x for what you gain plus negative 5 for what you lose. Negative 5 times 26 minus x, and the total should be 0. These two expressions are exactly the same. One is saying how much you gain is equal to how much you lose, and the other saying total gained is a positive, total lost is a negative. When you add them together, you break even at 0. You don't gain or lose overall. But if you rearrange this equation, you'll get this equation. Now let's solve this. This looks like a linear equation, so we'll just distribute the 5 and the combined like terms. So we have 8x equal to 5 times 26, which is 130, minus 5x. Then we add 5x to both sides, so we end up with 13x is equal to 130. And dividing both sides by 13, we get 10. So the question is, number solved correctly, since x represented that number, it's 10 problems. And there we have it. And let's go on to this question here. Two cyclists leave a city at the same time. One going east and the other going west. The westbound cyclist bikes 5 miles per hour faster than the eastbound cyclist. After 6 hours, they are 246 miles apart. How fast is each cyclist going? Now let's again do a diagram here. They're asking how fast is each cyclist going. So we should have two answers to this question. And so what I will do is I'll start off with a starting point, and we have one cyclist going to the east, which is typically to the right on the paper, and the other cyclist going to the west. Now let's see here. They say that the westbound cyclist is going 5 miles per hour faster than the eastbound cyclist. So the westbound cyclist the speed or the rate is 5 plus whatever the rate is for the eastbound cyclist. So let's say the eastbound cyclist rate, let's call that R, which means the westbound cyclist, that rate is R plus another 5 miles per hour. Now, the time both of them are traveling is the same. They start at the same time. So that means both have been traveling for the same time, which in this case is 6 hours. So they both are traveling for 6 hours. And their total distance apart after 6 hours is 246 miles. So now once we see this, we can say, oh, it's a distance is equal to rate times time problem, or speed is equal to velocity times time. So the total distance is pretty simple to see from the graph here. It's the distance is the westbound distance. And I apologize for my writing here. It's not very clear penmanship. Westbound distance plus eastbound distance. And now let's see what that means. Total distance is 246 miles. Westbound distance is rate times time. So it's the rate times 6 hours. 6 times R plus 5. And eastbound distance is the rate 6 times R. And this becomes a very simple problem from there. We distribute the 6 and add R and subtract 30 from both sides, combine like terms. And so we get 216 is equal to 12R. And then we divide both sides by 12. When we divide both sides by 12, that becomes 18. So the rate, the speed, the eastbound cyclist. Let me just see if I can write it here. So the eastbound cyclist is going 18 miles per hour, and the westbound cyclist is going 5 miles per hour faster, which would be 23 miles per hour. And we can check that. We can check that by saying if we multiply 18 by 26, sorry, 18 by 6. If you multiply 18 by 6, that would be 6 times 8 is 48. 6 times 1 is 6 plus 4 is 10. So that would be 108 miles per hour. No, 108 miles. And 23 by 6 would be 6 times 3 is 18. 6 times 2 is 12 plus 1, 13. And when you add those together, you get 246 miles, which is the total distance across. And that's the end of that question. This next question is taken from the book Algebra and Trigonometry, 9th edition by Michael Sullivan III, and it's exercise 1.7, number 35. It says, a gardener has 46 feet of fencing to be used to enclose a rectangular garden that has a border 2 feet wide surrounding it, and the figure illustrates that. If the length of the garden is to be twice its width, what will be the dimensions of the garden? What is the area of the garden? Is part B and part C. If the length of the garden and the width of the garden are to be the same, what would be the dimensions of the garden then? And what would be the area of that square garden? So they're asking two sets of questions here. The first, the Garden, the diagram here is representing the garden, but it's not going to be the exact same deal. So for the first question, part A, they ask if the length of the garden is twice its width. And what we're going to do is just redraw the diagram to illustrate what they have. They're asking us about. So this is the outer fence, and this is the garden here. Now, what we're going to do is we need to find, they want the dimensions of the garden under the conditions given. So let's call the width of the garden W, which means the length of the garden is twice the width. So if the width is W, the length is 2W. All right. Now we also know that he has 46 feet of fencing to be used to enclose the garden with a border of 2 feet. So we know that the distance from the garden to the fence is 2 feet all the way around, which means if you look at this carefully, if you want to find the distance of the fence here, it's really the W on the width side plus 2 feet for the going up and 2 feet going downward. In other words, if we're looking only at the fence, the width side is W plus 4, and the length side is the same deal. 2 feet going to the left, 2 feet to the right, and then the length is 2W. So we're talking about 2 feet here, 2 feet here, and then the width of the garden. That's a total of 2W plus 4. That's now the total perimeter, the total distance around the garden is going to be 46 because that's all the fencing he has. So the perimeter of the garden in all these cases is going to be 46 feet. And of course, that's the information they tell us. Now, the strategy here would be just use the perimeter. The perimeter is equal to twice the length plus twice the width, or add up all the side lengths. So the perimeter here, let me rewrite that a bit, twice length plus twice width. And we have to be very careful here. We're looking at the fencing around. So the perimeter of the fencing around is 46 feet. The length is 2W plus 4. And the width is W plus 4. So it's pretty easy now to solve this equation. We simply combine like terms. 46 is equal to 2W plus W, which is 3W. And 4 plus 4 is 8. And then as we go about solving that, we subtract 8 from both sides, and we get 38 is equal to 3W. Let's check to make sure. So since we have 46 feet of fencing to be enclosed to enclose the border, we have the width plus 2 plus another 2, that's the width plus 4. And the length is 2W plus 2 plus 2, so the length is 2W plus another 4. We add those up twice. That's what I forgot to do here. So I'm going to multiply this by 2 because it's twice the length plus twice the width. So that gives me, let me make a quick correction here. 46 is equal to 6W plus 16. And now let's correct that. Subtract the 16 from both sides, we get 30 is equal to 6W, which means the width would therefore have to be 5 feet. So for part A then, for part A, the width of the garden would have to be 5 feet, and the length of the garden would have to be twice that, which is 10 feet. And then part B is asking what is the area of the garden. which is now easy because it's a rectangular garden. We just do length times width. 5 feet multiplied by 10 feet. And that would give the garden an area of 50 squared feet. Now for part C, and I'm going to just create a little separating border here so that there's less confusion. And this time, the question is asking, what if the length and width of the garden were the same? Now, if the length and the width of the garden were the same, we'll have a square garden, and that will force the border around the garden to also be a square. So let's draw a little square here to represent the garden and another square to represent the fencing around the garden. So this is part C. In this case, the length and the width are both the same. And we still remember that the margin is still 2 feet each way, away between the garden and the fence. And we're going to use the same idea that we did before. So the distance from across here is the W plus 2 feet one way, 2 feet another way, that's 4. And the other side will also be W plus 4 since we're talking about a square. And therefore the perimeter now is simply going to be 4 times the side lengths. We're talking about square here. Or you could just add up all the sides, but it's 4 sides all of the same length. So the perimeter is still 46 feet, but now the 4 side lengths are W plus 4. We solve this equation. We can divide by 4 first, but in this case I would prefer to distribute. 4 times W, 4 times 4 is 16. We solve for W. We get 4W is equal to 30. And then we get that W would be equal to 7.5 feet. So the dimensions of the garden would then be 7.5 feet by 7.5 feet. And the area of the garden, which would be part D, would simply be the square of 7.5. And we can do that on our calculator. I'll just bring up the calculator on the screen here. And then once we do that on the calculator, we just put the answer in. So we do 7.5 multiplied by 7.5 is 56.25 square feet. And that's the answer to the question. It seems it's better to make it a square garden rather than the dimensions that was given in part A. Now, please try other questions. Again, this turned out not to be a quadratic equation, but we'll have to see what will happen when we try quadratic equations. But try other equations, try other questions on your own, and see how you can use the problem-solving approach to come up with an equation and then solve it. That's all for this exercise. And once again, I recommend you try Khan Academy for additional examples and practice. Bye.